Assalamualaikum everyone, my name is Nur Atika binti Mama Asri, and today I will present to all of you my microteaching for MAE 403. And let's start. But before we start, let's watch a video first, okay?
Hey, stop for musical chairs, come on, let's go. Set up the chairs, now all in a row. You run around the chairs till the music stops, and you have to find a seat, now don't get caught, 'cause when the music stops, you can't be standing there if you want to be a winner at musical chairs. Now we take away a chair while you're running around. Don't let the kid in front of you get you down. Just listen to the rhythm now, don't miss a beat, 'cause you don't want to be the only one without a seat. 'Cause when the music stops, you can't be standing there if you want to be a winner at musical chairs. Now, every time the music stops, you're gonna end up one chair short. And if you're boogalooing when the music's gone, sorry, you gotta move on. Now it's the moment of truth that's getting down the wire. You're burning up inside with musical fire. You hover around each corner of the precious seat, waiting for the moment you can get off your feet. 'Cause when the music stops, you can't be standing there if you want to be a winner. You got to be a winner if you want to be a winner at musical chairs. Yeah!
The video somewhat has a close relation with what we are going to learn today. Of course, it's not about music chair, but it's about rearranging and arrangement. Can you get the hint from this video? So today, we are going to learn about combination. Stay tuned. Before we define combination, let's look at the following scenario. A two-seater sofa is used for a photo session. 5 students, A, B, C, D, and E, will sit on the sofa to have their photo taken. This means that each time only the photo of 2 students can be taken. How many different photos can be taken? Surely you can see that this is a permutation problem. The photo with student AB is different from the photo of student BA. The number of different photos taken is 5p2 equal to 5 times 4, which is equal to 20. These are all the possible permutation for the photo session taking. After the photo session, 2 students are told to go to the staff room.
来る気なかったんだけどさ。いやー、ボロボロだね。
Who are the 2 students chosen to go to the staff room? This time, there is no difference between students AB and students BA. In both cases, it is the same students who go to the staff room. As the order does not make any sense, this is referred to as a combination. Hence, the number of combinations of 2 students out of 5 students is 5p2 over 2 factorial, which is equal to 20 over 2 and equal to 10. The number of combination of art objects from n different objects is the number of ways to select art objects from n objects where the order is not important. The value is given by the 2 formula. Students may use any of the 2 formula. The first one is number of combination equal to n factorial over art factorial times with n minus art factorial. Or students can use the second formula, which is the number of combination equal to the number of permutation over art factorial. Even though permutation and combination seems like the same thing, they are, however, have visible differences. Permutation is used to solve the problem when the order of selection is a factor, which, for example, we use it if we are about to pick the first, second, and third prize winner. The order and names must be specific. While for combination, we use it when the order of selection is not a factor. For example, we use combination when we are about to pick the winner and there is no order for the prize winner, which we just pick whoever the students who are winning and there is no first, second, and third prize winner like permutation before. Can you see the difference now? Permutation is when the order of selection is a factor and combination is when the order of selection is not a factor. Okay, remember that. Scientific calculator can be used to find the value of the combination. And here I will provide you with the instruction on how to find the function in the calculator.
Hello everyone. First you need to on it and then press shift and go to division symbol and you will get your C. Then put an in front of C and R behind it, and with that you will get your answer.
So to find out more about combination, let's do the exercise. For this, we will start with the example for combination without condition first. Alright? So we go to our first example. There are 30 students in a class. Each student is required to shake hands with every other student. How many times do they shake hands? For the solution, since it is common sense, we assume that each time 2 students are chosen to shake hands. So, the total number for 30 students will be, if we are using the calculator function, we will eventually get the answer straight away, which is 435. But if we want to show the solution done, we need to use one of the formula. So in this worksheet, I use the formula of 30 factorial over 30 minus 2 factorial and times with 2 factorial. So we will get the same answer, which is 435. For the second example, we have to solve the international problem. Uraraka, Deku, Shoto, and Kachan are at Justin Bieber concert. A stagehand comes up to the groups and tells them that 3 of them can go backstage to meet the singer. How many different groupings are possible? If we use the counting principle, we will make 3 slots. First, the slots with numbers and multiply to get 24 different groups, which the first slot is 4, second slot is 3, third slot is 2, and the last slot is 1 with equal to 24. And you can see that if we are using the counting principle, it is the same as we use the permutation. If we try to list all of the possible groups, we will run out of groups long before we get to 24. In fact, there are only 4 groups possible. Each groups pick 3 persons and leave 1 person out. It's easy to make the list if we just leave a different person out each time we make an entry to the list. Here are the 4 possible groups. The Justin Bieber problem could be solved using this formula. In this case, the n is equal to 4 as the groups has 4 people and the r equal to 3 as only 3 of them can go backstage. So, the answer will be 4. Thus, there are 4 possible groups. Any other groups you might list would just be one of this group with the name rearranged. The counting principles overcounts when only the object selected is important and the order that they are selected is not important. Combination is so easy to be understood, right? Now, the real question is, who will be the one left out from meeting Justin Bieber? Now, that's a real question. The third problems that we have to solve today is the school meeting problems. How many different ways can 3 people from Yuji, Megumi, Nobara, Toge, and Maki be selected to attend a meeting? Before putting pencil to paper, we need to ask ourselves if the order of the people selected is important or not. If we think the order is important, then it is a permutation problem and we can use the permutation formula or by using counting principle by making lines and then multiply. If we think the order is not important, then we need to use this combination formula. This is if we think picking Megumi, Yuji and Toge to attend meeting is different from picking Toge, Yuji and Megumi to attend the meeting, we will solve this problem using the technique from previous equation. I don't think this would be correct. The order we list the people selected to attend a meeting is likely not important. This is supposed to be a combination problem. Thus, we will solve it using the combination formula. It's the same as the previous question, the Justin Bieber's problem. We start by excluding the 2% first and then we will get groups that will attend the meeting, where we will get 10 possible groups. Our work will be much easier by using the combination formula. So, by using the combination formula where n is equal to 5 and r is equal to 3, the number of groups that will likely to attend the meeting will be 10. We have done with exercise for combination without condition, and let's move on to the combination with condition exercise. Let's go to our first example. A committee of 5 people is to be chosen from a group of 6 men and 4 women. How many committees are possible if, in case 1, there are no restrictions? In case 2, one particular person must be chosen on the committee, and for the third case, one particular woman must be excluded from the committee. Let's go to our first case. If the question told us that there is no restriction, then it means that the question is the same as the combination without condition, where we need to use the problem like always. Thus, n is equal to 10, because the number of people is 10 and r is 5, as the number of committee spot needed is 5. By using the formula or your calculator, the number of possible committee form is 252. The second problem is one particular person must be chosen on the committee. By saying one particular person must be joining the committee, it is the same as one spot in the committee has been taken. There are originally 5 spots in the committee, and then after that one person has reserved the spot, the remaining spots become 4. Since that one person has secured his or her spot, there is no need for him or her to be with the other 9 anymore. Thus, the number n become 9 and r become 4. By using the calculator and the formula, the answer will be 126. The third question is one particular woman must be excluded from the committee. This means that out of 4 women, one must be excluded from joining the committee. Maybe because she had problem at work? I don't know. Since one person is excluded from the group, then the total number of person in the group is reduced from 10 to 9. This is significant because n that we needed to use will be 9 instead of 10 like earlier. However, r is stay the same, which is 5 because the committee seats. This does not differ. By using the calculator and the formula, the answer will be 126. The second example has the situation same as before, where a committee of 5 people is to be chosen from a group of 6 boys and 4 girls. How many committees are possible if the first case where there are 3 boys and 2 girls, second case where there are to be boys only, and the third case where there is to be a majority of girls? The first case, there are to be 3 boys and 2 girls to join the committee, which means for the committee seat, out of 6 boys, only 3 will be chosen from the groups, and out of 4 girls, only 2 persons will be chosen to join the committee. Under this condition, there will be separate condition, since the condition split into genders. For boys group, there are 6 of the boys in the group, and were only 3 seats will be given to the boys to join the committee. Thus, the N for this condition will be 6 and the R will be 3, which equivalent to 20 groups of prospect boys committee. For the other gender side, the total number of girls in the groups is 4, and there are only 2 seats available to be given to prospect girls committee. Thus, N will be the total number of total girls and R will be 2, which indicate the seats. With using the calculator or the formula, there will be 6 groups of prospect committee. In order to find the total from 2 groups of possible committees, we need to times the total of the 2 situations, which we will get 120 possible groups of the committee. For the second case, only boys are allowed to be in the committee. Total number of boys in the group is 6 and the spot open is just 5. This situation is same as Justin Bieber problem, where we need to exclude 1 person from each group selection. For this, N is 6 for the total number of boys in the group and R is 5 for the spot. That being said, after using the calculator or the formula, the total groups for this situation is 6. Next is the third case. The third case situation is about what if there is to be a majority of girls in the committee seats. Since we have only 4 girls in the groups, for this matter, we can say that there are 2 possible situations. In order for girls to be in majority seats, out of 5 seats, girls should take at least 4 or 3 seats for them to be in the majority. For this, when there are 3 girls in the seat, only 2 seats left for boys. Or when there are 4 girls in the seats, only 1 seat will be left for boys. Thus, for situation with 3 girls on seat and only 2 left for boys, for this matter, the possible girl committee will be 4, while for boys, the group that will get to be in the committee will be 15. For another situation, the girl with majority 4 seats and boys with 1 seat, the group formed for this situation will be 1 and 6 for girls and boys respectively. Since this case required 2 possible situations to happen, then we need to sum the 2 situations and we will get a total of 66 possible groups that can be formed. In this method, the word "or" indicate the plus sign. Example 3. 6 tourists rented 2 cars, A and B. The capacity of each car is 4 passengers. Given that all the 6 tourists can travel in any car, in how many ways can they travel in the 2 cars? There are 3 possible cases in this situation where car A and car B carries 4 and 2 tourists respectively. Case 2 is where car A and car B each carries 3 tourists, and lastly, case 3 where car A and car B each carries 2 and 4 tourists respectively. For case 1, where car A and car B carry 4 and 2 tourists respectively, N will be 6 since the total tourists is 6. However, The situation requires 4 tourists on car A. Thus, art will be 4. While for car B, the rest of the tourists that did not get on car, which is 2 person, will become the N and art, which is 2. The possible ways that the tourists can ride the car are 15 ways in this situation. Case 2 situation is where car A and car B each carries 3 tourists. For car A situation, and for car A will be 6, while the art will be 3. The rest of it, which is 3 tourists, will end up in car B, where N will be 3 and art also will be 3. The possible way that the tourists can ride the car are 20 ways in this situation. For case 3, car A and car B carry 2 and 4 tourists respectively. It is the same as case 1, however, the car is not the same. For car A, N is still the same, which is 6, while art is 2. The rest of the tourists, which is 4 of them, will end up in car B. N and art for car B will be 4, and the total ways for case 3 will be 15. The real question for example 3 is to find all of the possible ways that the tourists can travel in the car. For this, they need to add all of the ways prior, which will end up to 50 ways possible.
That's all from me. Thank you.